Think about the last car you saw on the road. Maybe it was a BMW, maybe a brand new Hyundai, maybe a massive construction machine heading toward a job site. At some point before that vehicle reached its destination, there is a good chance it spent time inside a ship, but not inside a container. It was driven straight into the vessel, parked on one of several enormous decks, secured in place, carried across the ocean, and then driven out again at the other end. That is the basic idea behind a roll-on, roll-off ship, usually called a ro-ro. And once you understand how these ships work, the process of moving thousands of vehicles across the world starts to look very different. A modern ro-ro vessel can resemble a floating parking garage several stories high. Instead of containers being lifted by giant cranes, vehicles enter through ramps and move under their own power. Cars, trucks, buses, trailers, construction equipment, and in some specialized vessels, even railway vehicles, can all be transported this way. Some of the world's largest vehicle carriers can hold thousands of automobiles on a single voyage. And that raises a simple question: how do you safely put thousands of vehicles inside a ship, keep them secure while the ocean is moving beneath them, and then unload the entire cargo without turning the process into chaos? The answer is a remarkably organized system that begins long before the ship leaves the port. When a vehicle leaves a manufacturing plant, its journey may already involve several different forms of transportation. A newly built car is usually moved from the factory to a port by road or rail. Large vehicle trains can carry hundreds of automobiles at a time, while specialized trucks are used for shorter distances or for vehicles that cannot easily be moved by rail. But arriving at the port is only the beginning. Before a vehicle can enter a ro-ro ship, it has to be processed. Its condition is inspected and recorded. Any existing damage, scratches, dents, or other visible issues may be documented so that there is a clear record of the vehicle before loading. The shipping documents also contain important information about the vehicle, including its dimensions, weight, destination, and handling requirements. Then comes one of the most important parts of the entire operation: deciding where every vehicle will go. A ro-ro ship is not simply filled from the front to the back. Every vehicle has a planned position. The loading team has to consider the size and weight of the vehicles, the destination of the cargo, the available deck space, and most importantly, the balance of the ship. It is a little like solving an enormous three-dimensional parking puzzle. Except this parking lot is floating in the ocean, and getting the arrangement wrong can affect the vessel's stability. The vehicles themselves also have to meet safety requirements before they are loaded. Fuel levels are controlled according to the ship's procedures. Personal belongings are generally prohibited, and vehicles must be in suitable operating condition for the loading process. Tires, loose components, and other potential problems may be checked before the vehicle is allowed aboard. Once everything is cleared, the real operation begins. The ship approaches the terminal and secures itself at the berth. At the stern, or rear of the vessel, a large loading ramp is positioned between the ship and the terminal. This ramp is the defining feature of a ro-ro vessel. There is no need for a giant crane to lift each car from the dock and place it inside. The vehicles simply drive aboard. That sounds simple, but imagine doing it with thousands of vehicles, each of which has to end up in a specific location. The people responsible for this operation are known as stevedores, or vehicle handling crews. They move the vehicles through the ship, following the loading plan prepared before the operation begins. One vehicle enters, then another, then another. Soon, the ship's enormous internal decks begin filling with rows of cars and trucks. Inside, the scale can be difficult to appreciate. A ro-ro ship can have multiple vehicle decks connected by internal ramps or adjustable platforms. Some decks are designed for standard automobiles, while others may accommodate taller or heavier vehicles. Certain decks can also be adjusted to create more usable space depending on the cargo. From the outside, the vessel may look like a giant steel box. Inside, it is closer to a multi-level parking structure. But there is one major difference. A parking garage doesn't have to survive a storm in the middle of the ocean. Every vehicle must therefore be secured. After a car reaches its assigned position, Workers use specialized lashings and securing equipment to connect the vehicle to designated points on the deck. The goal is to prevent unwanted movement as the vessel rolls, pitches, and experiences the forces created by waves and wind. The securing arrangement varies depending on the vehicle and the ship, but the principle is always the same. The vehicle cannot simply be parked. It has to be tied down, and the entire ship has to be loaded in a way that keeps its weight properly distributed. This is why the loading plan matters so much. A ship carrying thousands of vehicles is not just transporting cargo. It is constantly managing weight, stability, and space. When loading is complete, the ramps are secured, the vessel leaves the berth, and the vehicles begin the next stage of their journey. For the people outside the ship, it may look like nothing is happening, but inside, the vessel is operating as a carefully controlled system. The vehicles remain shut down and secured while the ship moves across the ocean. Crew members monitor the vessel and regularly inspect critical areas. They may check securing arrangements, ventilation systems, fire safety equipment, and the condition of the decks. Fire protection is especially important on vehicle carriers because thousands of vehicles are being transported within enclosed spaces. The ship itself is also constantly being monitored. Navigation systems track the vessel's position. Engineers monitor the propulsion system and machinery. Officers watch weather conditions and sea conditions, and the route can be adjusted when necessary. A ro-ro ship may travel at roughly 18 to 20 knots, depending on its design and operating conditions. But speed is only one part of the equation. The vessel has to reach its destination safely while maintaining stability and protecting the cargo throughout the voyage. And the routes can stretch across enormous distances. A vehicle manufactured in one part of the world can begin its journey at a factory, travel by rail or truck to a port, cross an ocean aboard a ro-ro vessel, and then continue by road or rail toward its final destination. The buyer may see only the final delivery, but behind that delivery is an international logistics network involving factories, railways, highways, ports, ships, customs authorities, shipping companies, and dealerships. Eventually, the vessel reaches its destination, and then the entire process happens in reverse. The ship approaches the terminal and secures itself. The stern ramp is lowered, but before the vehicles can move, the lashings have to be removed. Workers go through the decks systematically, releasing the vehicles from their securing once points. And once again, the order matters. The first vehicles unloaded are not necessarily the first ones that entered the ship. The unloadings in sequence is planned according to the vessel's cargo arrangement and the destinations of the vehicles. The wrong sequence could create unnecessary movement of cargo and affect the ship's weight distribution. So the vehicles are released according to a carefully prepared plan. One by one, they start moving. The engines come to life. A car that may have spent days or weeks inside a steel ship suddenly drives into daylight, then another follows, and another. Thousands of vehicles can eventually leave the vessel through the same ramp they used to enter. At the terminal, the vehicles move into designated areas where customs and import procedures can take place. Depending on the country and the type of cargo, authorities may check documentation, duties, regulations, and other requirements before the vehicles can continue toward their final owners or dealers. The entire unloading operation can also be remarkably fast. A large ro-ro vessel can discharge a huge amount of vehicle cargo in a matter of hours, depending on the ship, port, cargo arrangement, and terminal operation. And this is one of the biggest advantages of the ro-ro system. The cargo doesn't have to be individually lifted out of containers. It simply drives away. But not every ro-ro vessel is designed for exactly the same job. Some are specialized pure car carriers, often called PCCs. These vessels are designed primarily to transport automobiles. Others are pure car and truck carriers, or PCTCs, which can handle a wider range of vehicles, including cars, trucks, buses, and heavy equipment. Then there are combination vessels designed to transport wheeled cargo alongside other types of freight. And there are ro-ro passenger vessels, commonly associated with ferries, where vehicles and people travel on the same ship. This flexibility is one reason the basic ro-ro concept has become so important to global transportation. Cars are only part of the story. Think about a bulldozer, a road roller, a tractor, a fire truck, a bus, a military support vehicle, a massive piece of construction equipment. Many of these machines are difficult or inefficient to transport using conventional containerized shipping. But if the vehicle can be driven onto a ship, the problem becomes much simpler. Drive it in, secure it, transport it, drive it out. That simple idea has transformed the movement of wheeled cargo around the world, and the system is not limited to international ocean routes. India has also been developing ro-ro and related roll-on, roll-off transportation as part of efforts to use waterways more efficiently. Projects connected with the country's broader port and inland waterway development have explored ways of moving vehicles and freight by water instead of relying entirely on highways. One example is the ro-ro ferry connection between Goga and Dahej in Gujarat. The concept is straightforward. Instead of forcing every truck to travel the entire distance by road, some vehicles can be carried across the water. That can reduce road congestion and, depending on the route and operation, reduce travel time and fuel consumption. The same principle applies to inland waterways. A truck that spends hours navigating congested roads can potentially be moved by vessel while its driver and cargo avoid part of the road journey. For a country with a huge road network and rapidly growing freight demand, that creates an important alternative. There is also an environmental argument. Heavy trucks consume significant amounts of fuel and contribute to road wear. Moving large quantities of freight by water can, on suitable routes, use energy more efficiently per unit of cargo. But ro-ro shipping is not a magic replacement for roads or railways. It works best when ports, waterways, terminals, highways, rail connections, and logistics networks are properly integrated. A ship can move thousands of vehicles efficiently, but those vehicles still have to reach the port in the first place. And once they leave the ship, they still need a final connection to their destination. That is why modern transportation is really a chain. The factory is one link, the truck or railway is another, the port is another, the ship is another, and the final road journey completes the chain. The remarkable part is how invisible this system can be to the person who eventually buys the vehicle. You walk into a dealership, you choose a car, you sign the paperwork, and eventually, the keys are handed to you. It feels like the car has simply arrived. But before that moment, it may have traveled hundreds or thousands of miles by road and rail, spent time inside a port terminal, crossed the ocean aboard a specialized ship, passed through customs, and traveled through another transportation network before reaching the dealership. And somewhere along that journey, there may have been a ro-ro vessel carrying thousands of other vehicles beside it. That is what makes these ships so interesting. From the outside, they don't look particularly revolutionary. They are enormous steel vessels moving quietly between ports. But inside, they are carefully engineered transportation systems. Every deck has a purpose. Every vehicle has a position. Every securing point matters. Every ton of weight contributes to the ship's stability, and every movement is planned. The next time you see a new car on the road, or a huge construction machine being transported toward a building site, remember that its journey may have begun much more further away than it appears. It may have started in a factory thousands of miles from where you are standing. It may have crossed highways and railways before reaching the coast. And it may have spent days at sea inside one of the world's largest floating parking structures. The most remarkable thing about a ro-ro ship isn't simply that thousands of vehicles can fit inside it. It's that the entire process has been designed around one deceptively simple idea. Instead of lifting the vehicle to the cargo, bring the cargo to the vehicle, let it roll on, carry it across the water, and let it roll off. That simple principle connects factories to ports, ports to oceans, and oceans to the roads where those vehicles eventually become part of everyday life. The next time you see a car that seems to have appeared from nowhere, there is a good chance its real journey was much longer than you ever imagined. If you enjoyed discovering what really happens behind the scenes of global vehicle transportation, make sure to like this video and subscribe to the channel. We bring you more fascinating stories about the technology, systems, and hidden infrastructure that keep the modern world moving. And before you go, tell us in the comments, if you could watch the inside of any massive ship in the world, which one would it be? Thanks for watching, and we'll see you in the next documentary.